All right, so the printing's all done. Here is the housing, all 3D printed. Nothing is tacked in. And I'm going to use the brass rods. I don't think it's going to interfere that much. But the wire's going to go around like typical window motor, and then it'll go on like that. Of course, it's going to be up like that. So what I need to do now is take some measurements. I want to glue these feet, if you will, these support feet onto the base so that I can just slide these in there. And then take a measurement down here, cut the rods. You know, I looked for acrylic. Well, I didn't look for acrylic rods. I should have looked for those. But I looked for acrylic or plastic long threaded rod, and it's hard to find. So I just noticed one of the feet here are bent, nothing that a little heat can't take care of. So stay tuned. Too much heat. Got a little burn on there, but that's okay. Got it nice and straight. It was funny because when I first heated it up, I pressed my fingers on it like that and made indentations. Then I just put a little heat on there and they went away. But then I kept the heat on there just a little bit too long and it burnt it. Ugh. So I got to tell you, one of the greatest tools I've ever discovered was this deburring tool. And it's great because it comes with a bunch of these little replacements. And for doing plastic, it is the best. You just go like that and like that and like that, and it gets the edge off. So these weren't fitting too well, right? So then you just go rink, 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 rink like that. And then they slide on nice and tight. So yeah, so these go on like that. And I'm going to, I don't know if I'm going to glue these to this, to the base, or these to this and then to this. I don't know. I want to be able to take it off. So I think what I'm going to do is glue this foot to the base. Anyway, stay tuned. I also finished this coil. Remember the one, well, if you saw the last video, when I was winding it and I was taking it off of the coil winder, it was making all kinds of cracking sounds. That's because the two plastic pieces were separating. You can see, I don't know if you can see, but it's concaved on both sides actually. But it's still good. And I covered it in resin. So it should be good. But it's a bifilar coil, nice and heavy. That's how I check my coils, by weight. I don't do it the professional way. Anyway, it'll fit perfectly underneath here. I just have to figure out how I'm going to put the terminals on there. I was thinking about bending it over and putting them on the side here, which I think I might do. I'll have to figure that out. All right, stay tuned. All right, so I think this is how I'm going to do my coils from now on. Instead of putting the terminals on top, I'm going to put them on the side. This way I could slide it in there no problem. And it was weird because I was trying to figure out what I was going to put here to mount the terminals on. And I was taking plastic or acrylic that I had and trying to melt it. And then I realized, wait a minute, I have a 3D printer. So I just printed it out and it came out perfect. So this guy will sit like that, right? Put the this is the, right, yeah, this is the run, this is the pickup. Voila. I have the legs done. So now all I have to do is cut the brass rods that I have. And I really don't think the brass is going to do that much of a braking action on the rotor. I really don't. If it does, I'll change it out. I looked at 3D printing thin thin rods, but threaded rods, and I can do thick ones like these guys here. These are no problem. I 3D printed these out of that copper filament that I have, or the copper infused, and they came out really nice. But these, I think, are a little bit too big for this. Maybe not. Maybe that will work. I just have to make the holes bigger on these. But I think I might have overlooked something when I was designing these. So the wire is going to, go from one to the next one. And as it wraps around, it's going to fill these voids. And I may not have spaced them out far enough so that I can put one here, 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 and here. I'll have to see. Depends on two things: how much wire I wrap on each leg, and the thickness of the wire. I think I'm going to use the 23 gauge. But yeah, I'm going to have to figure all that out. So let me cut these to size, get them drilled and tapped because they're hollow. And I think they're the same ones I had before. These might be a little bit bigger. I might be able to just get away with just tapping these. And then I have the screws that I'm going to, or the bolts that I'm going to bolt them down with, I think. I think that's how I'm going to do it. I had made these just for a test, and they worked. I just drilled and tapped them. But I was really hoping to do something that was that was not brass or stainless steel, something non-ferrous. But I've been getting comments saying that if I use the if I use the brass rods, it's going to do a braking action on it. But I really don't think it will. It doesn't, it doesn't seem to be. See if I can feel it. We'll see. Worst case scenario is it doesn't work and I got to come up with something else. But I want to get it together and get it nice and tight and then start the wrapping process, because that's going to take a little while. But I got something really, really cool to show you guys. It'll be in the next video. It's really, really cool. Oh, I can't believe I got it. But I'll break it out in the next video. All right, stay tuned. All right, so I've got it together. It came out really nice. Of course, it doesn't have the wire on it. And so I know I'm going to get comments saying that the brass is going to cause a braking action on the rotor. Yes, that's probably true, but I don't think it's going to cause that much of a braking issue. What I'm going to do is I'm going to put this on here without any wire, run it up to speed, take a tach reading, do it at several different voltage levels, 12, 8, 6, and then take these off. And well, actually, I'll do a tach reading first on the rotor without this and see what kind of, and I'll actually use this coil, this run slash pickup coil. Take some readings, put this on there without the wire, take some readings and see if it's that much of a difference. Now, you guys might say, well, it's got nothing to do with the speed of the rotor. True, but I don't think it's going to make that much of a difference. And if it turns out to be too much, what I can do is, after I put the wire on here, I resin up the wire, then I can take these out. I can actually take these out and just leave the wire in there because it's being held together by the stand. And also, once the wire is in there, if it's resined up properly and, you know, crimped properly, it shouldn't need these supports. These supports are mainly there right now so that I can wrap the wire, if that makes sense. So yeah, it came out really nice. All 3D printed, obviously, except for the brass rods. And let's get some wrapping done. Stay tuned. All right, guys, really quick. So just to reiterate, there has been a couple of comments that I'm making a, you know, standard Bedini window motor. Yes and no. Actually, what I'm doing here is it's going to look like a window motor. It's going to look like a Bedini window motor, but it's not going to operate like one, because the coils that I'm going to wrap around here and then like so, and I haven't figured out, I'm going to do so many turns on each one. I'm actually going to count the turns, and I have it set up here because the only way to do this is by hand. This coil that I'm going to put on here, and it's going to be a single coil, I'm not going to do it by 5, is not going to run the maglev. This guy's going to run the maglev. The coils that I'm putting on here are simply for pickup, just to check it out, just to see what it would. Oops. Yeah, it's simply going to be a pickup coil of sorts. And I might be doing a whole lot of work for nothing, but I really don't care. It's kind of cool, and it looks really cool too. But yeah, so it's going to look a little bit like a Bedini window motor, but it's not going to operate like one. Right now, I'm printing out a riser for this coil that's going to sit right here to bring it up closer to the rotor. So it'll be about 2 millimeters away from the rotor. Maybe a little bit less, maybe a little bit more. I'm not exactly sure. I think it'll be just about 2 millimeters away. But yeah, so I'm going to get a wrapping. It's going to take a while. I'm using 23 gauge. Figured I'd split the difference between 21 and 25. And we'll see. What I may end up doing, like I said earlier, is once I get it wound and I'm happy with the way it is, I will secure it with resin and then take these brass rods out. Maybe leave 2 of them in. I don't know. It all depends on how well I can secure the wire to the housing, to the coil housing, and how well it's held together. I figure if I'm wrapping it like this, I can also use some sort of binder that wraps around this way, which would tighten up. And we'll see. We'll see. I may leave them in there. I may take them out. I may do both. All right. I can do both. It's my coil. Ciao. All right. So testing the coil. I put some support pieces on its side. Seems to be okay. Or the coil's good. Getting a lot of output. Again, the camera shows it blinking, but in IRL, it is not. And like I said, I got a couple of millimeters distance. Let's see how low we can go with the voltage. So that's 9.9. Let's see. There's 7.4. Still doing really nice. 7.3. There's 6.3. Still working. Again, IRL, it's a solid light. It's not as bright. Seems to be holding. I don't think I can go much lower than that, not with this circuit. This circuit likes to run at 12 and even higher. There's 5.8. And it's running nice. Oh, just jumped up to 6.3. I don't know how that happened. There's 5.9. 6.0 again. There we go. 4.950. So 5 volts. And it's still running good. The light is very, very dim. But it'll run successfully at 5 volts. And that is the JL94 circuit, the Sky Collection circuit. Probably the best circuit to run any of these pulse motors, in my opinion. I mean, I like the Bedini circuit. It's cool. I like using the Hall sensor. That's kind of cool, but this guy never fails. 4.9. 4 point, yeah, so it's running barely. Let's see if I jot it down to 4.7. It's still running. Very nice. Anyway, I've been putting off winding this coil. I hate winding coil. I've been putting it off. I wanted to test this motor, and I'm using the 25 gauge wire as the run coil. Coil came out nice. All right, I got to stop messing around, and let me see how low I can go. Now I'm at 3.8. It's not putting out anything now as far as, but it's still running at 3.8. Nice. Now let's juice it back up. There it is. All right, let me stop playing around. Stay tuned. All right, so far so good. So I'm putting 50 turns on each peg. And it was really weird. The reason why I stopped was right in the middle of this, I had my hot glue gun plugged in. And it was just sitting over there next to my homemade disc sander. And it was just sitting there. Then all of a sudden it went zzz, and a big puff of smoke. So something happened on the inside and it shorted out. And it's too bad. It was my best one. It was a Stanley. And it worked really good. Now the garage stinks like burnt plastic. Anyway, let me get back to rolling, winding. Ciao. It's looking good. But man, talk about cramps. So I have two more pegs, or two more, I don't know what you'd call them. And then I got to figure out if I'm going to like pinch these together to make them tighter or leave them like they are. Maybe what I'll do is I'll just put a lot of crazy glue on the ends here, and then I can determine whether I'm going to take out excuse me, the brass rods. All right, let me get this thing finished. 50 on each. Stay tuned. All right, she's finished. And I actually ended on this side, but then I went like this one time so that I can end on this side. So I know where the start is, I know where the finish is. Not that it's going to make that much difference, because again, this is only going to be a pickup coil. I wanted to terminate on one corner, but it didn't come out too bad. I have one loose strand here. I'm not really sure what happened, but it's not loose, you know what I mean? It's just kind of sticking out, but came out nice. I mean, it's not wound beautifully, but it'll work. So now I'm going to drizzle crazy glue on the ends there. Stay tuned. All right, there we go. So I decided to put a zip tie, not super tight, just enough to snug it up. And I put some crazy glue on the ends there. What I'm going to also do is print out some little caps for that so that the wire can't come off accidentally like. And see what I can do with some resin. All right, stay tuned. All right, so all I have left to do is hot glue the terminal to the side, and it is done. Not so bad looking, huh? I put the caps on there, you know, so the wire wouldn't come off, but it really wouldn't because I crazy glue, so it's more for decoration purposes. Yeah. And we'll get this guy hooked up. Let me see what I got going on there. Oh yeah, he's looking good. I think I have to adjust that though before I run it. But anyway, it's looking pretty good. I'm still unsure on whether to take out the brass rods. I suppose I could take this one, and this one out just to see what would happen. I'm afraid if I take them out, the wire's going to try to collapse it, but I think the wire's stiff enough where it won't collapse it. Anyway, let me get this thing glued up and then see what we can do. Ciao. Looking pretty nice. Give that a little spin. Yeah. I think I will try to see if it'll run off of that coil just for kicks. I don't think it will because of the way it's set up. I gotta take a picture so I can do a thumbnail. I never usually do that. All right, guys. Stay tuned.